right, guys, so today we are going to talk real quick about exponents. So you should be, I know you guys are familiar with exponents. You started using exponents in 6th grade. But this year we're going to focus more on exponent rules, how to multiply, add, subtract, multiply, and divide with exponents. All right, so our standard and our learning objectives. An exponential number or expression is composed of two parts. First, the big number, that number to the left, is called the base, and the exponent is the little number. It's always raised up to an exponent. So that's the second component, which sites on the base's upper right corner. So this, since there is an exponent present, this whole thing would be considered an exponential expression. Exponential expression. Exponents represent repeated multiplication. Exponents tell us how many times to repeat the multiplication. For example, if I see 4 to the second power, or when it's a 2, you can always say squared. So this is 4 squared. That means we're going to multiply 4 together twice. 4 times 4. X squared, or x to the second power, we would write it x times x. Here we have 5 raised to the 5th power, and that means you're going to multiply 5 together 5 times. So this part on the right, this is called expanded form. All right, here's another example. If we have, if we're going from standard form to exponential form, this is what this would look like. So 3 times 3 times 3, we would write that 3 to the 3rd power. Or if it's the exponent is a 3, you can always say cubed. So 3 cubed is 27. 7 times 7 times 7 times 7 times 7, we would write it 7 to the 5th power. And this expression right here, we have 4 x's being multiplied and 2 y's being multiplied. So we would write that x to the 4th times y squared, or x to the 4th power times y squared, or y to the 2nd power. And that is written in exponential form. All right, so let's look at some problems. Hopefully you guys could answer all of these. So if these are written in expanded form, how would we write them in exponential form? Well, the first one, let me turn my pen on. The first one we would write as k to the 1, 2, 3, 4, 5, 6th power. So we would write this k to the 6th power. That doesn't look like a k, but it's supposed to be. All right, what about this? We have 4 3s, so we're going to write 3 to the 4th power times 5 squared. You don't even need multiplication. That just means if it's squished up next to each other, it means it's all being multiplied together. 5 squared times x squared times z. I'm sorry, my board is on a weird slant, and so I'm writing kind of funkily. Is that a word? No, I don't think it is. All right, what about 2 g's? We would say g squared, or g to the 2nd power. 8, how many 8s do we have here? We just have 1. So this will be written as 8 to the 1st power. We have 1, 2, 3, 4, 5, 2. So we would write this 2 to the 5th power. All right, how many y's are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we would write 11, or excuse me, y to the 11th power. And down here, we would write 4 cubed times j times k squared times m to the 4th. Okie dokie. Easy peasy. All right, the next one, we're asked to do the opposite. They want us to take the exponential form and write them in expanded form. So this would be 6 t's multiplied together. 1, 2, 3, 4, 5, 6. All right, I'm not going to go through all these. You guys know how to do this, right? I'm not going to write all that out because you know the answers already. All right, so we do want to talk about just a few of our rules today that we're going to save most of them for next week. Now, if you are in your lunch point, you have to open BrainPop through Launch Point first, and then you can watch this absolutely entertaining video of Tim and Moby. So please do so. All right, so one of the properties I want you guys to know is that any variable or number raised to the 0 power is equal to 1. So x raised to the 0 power is 1. 4 raised to the 0 power is 1. A huge number like 543,679,000 raised to the 0 power equals 1. That's always true. So even if you have a negative number, like if you have negative 3 raised to the 0 power, as long as that negative sign is in parentheses, the answer is always positive 1. If I have negative 2 raised to the 0 power, the answer is positive 1. If I have negative 1014 raised to the 0 power, the answer is still 1. However, if you drop those parentheses and you write a problem like this, the answer is, the answer is negative 1. If there's no parentheses around the negative sign, and you type this directly in your calculator, just like I've written it, negative 2 to the 0 power, the answer is negative 1. Okay, so you got to keep that little thing in your brain because that will be coming up. Need to remember that. All right, so let's look at these examples here. So if I said what is 2 to the 5th power, it equals 32. If I say what is 2 to the 4th power, it's 16. 2 to the 3rd power would be 2 times 2 times 2, which is 8. 2 to the 4th power is 4. 2 to the 2nd power is 4. 2 to the 1st power is 2. All right, so if you see this pattern here, each number is half the previous number, right? So math follows patterns. So if we continue the pattern, if 2 to the 1st power is 2, and based on the pattern, if we go down one exponent, the next number should be half of 2. So that's one of the reasons why 2 to the 0 power is 1. That's the only way this pattern would continue. All right, let's look at the next pattern. 3 times 3 times 3 times 3 times 3 equals 243. 3 to the 4th is 81. 81 is a third of 243. 3 times 3 times 3 is 27. 27 is a third of 81. 3 squared is 9. 9 is a third of 27. 3 to the 1st power is 3, which is a third of 9. So the next number would have to be a third of 3. Well, guess what? 1/3 of 3 is 1. Once again, our pattern continues because of this rule right here. 2 to the 0 power, 3 to the 0 power. Well, when you have tens raised to an exponent, basically that exponent tells you how many zeros there are. You see that? So 10 to the 4th power, there's 4 zeros. 10 to the 3rd power would be 1 followed by 3 zeros. 10 squared, same thing as 10 times 10 is 100, 2 zeros. 10 to the 1st power has only 1 zero. And 10 to the 0 power is just 1. No zeros. No zeros. All right, so once again, that weird rule of anything raised to the 0 power is 1, it makes sense because that answer on each one of these fits the pattern and it makes sense mathematically. So that's that's the reason that anything raised to the 0 power is 1. All right, now this one can get people a little confused. If you have an exponent raised to a negative power, in order to make that negative go away, you have to flip that number to the other side of the bar. So for example, b, the way it's written is b over 1 would be b in the numerator. Well, to get rid of that negative sign, you would have to flip b from the numerator where it starts out at into the denominator. Or if you see a problem like this, 1 over b or any number raised to the negative power, you have to flip it up to the numerator. So it would flip up to just positive b to the positive nth. Okay, so any non-zero number raised to a negative exponent is not in simplest form. You have to rewrite it. Using this property, move the base with the negative exponent to the opposite side of the fraction, and then the exponent becomes positive. So Of course, you know any number, like if I just had the number 5, that means if I wrote this as a fraction, 5 is in the numerator, okay? So if I have 5 raised to the negative 1, that means 5's got to flip over that fraction bar. It's got to go down into the denominator, and then my negative becomes, my negative sign goes away. Okay, so let's look at this first example. I know these are all variables, but this works with numbers as well. So e raised to the negative third, that's, if I wrote that as a fraction, it'd be e over 1. So to make that negative sign go away, I got to flip this number over the line. So there's a saying, flip over the line, change the sign. So when you flip it over the fraction line, it changes to a positive, okay? This original problem, 1 over x to the negative second, we want that to be a positive exponent. So we got to flip it over the line to change that sign from negative exponent to a positive exponent. All right, look at this example. Only the x on the top is raised to the negative power, not the y. So when we simplify it, the y stays on top. The x gets sent down to the denominator, and the exponent becomes positive. The z, which is negative written in the original problem, we got to flip it up over the line, and it becomes z to the positive fifth. All right, so look at that for a minute and see if it makes sense to you. All right, now you guys try these, okay? So here we have k to the negative second. So k is sitting up here in the numerator. I'm going to flip it over the line. I'm going to change that sign to a positive 2. Now, in a fraction, you can't have the top blank. You can't have a blank there. You must put a 1 on the top. All right, let's look at let me change colors. That red is a little hard to see. All right, does our 2 change position? No, it stays on top. Oh, that's even worse, you guys. Let's try blue. So 2 doesn't change anywhere. It's on the top. It stays on the top. Y has the negative exponent, so it moves up here with the 2, and the exponent becomes positive. And really, I don't even need a denominator of 1. Do you agree? So really, my answer is 2y to the third. All right, here's a complicated one right here. Let's see what we're going to only move. The numbers or variables that are attached to a negative exponent. So is the 3 attached to a negative exponent? No, it's just a 3. So it stays on top. What about my x? My x squared, this whole thing right here moves down to the denominator. I'm going to write x squared for the positive 2. Y to the fourth has a positive exponent. It stays on the top. Now let's go to the bottom. K squared doesn't move because that has a positive exponent, k squared. But m to the negative 8, we got to move that up. Move it up to the numerator, and I'm going to write m to the positive 8. And now it's simplified because now all of our exponents are positive. All right, so we're going to try a few together, you guys, and then that's going to be the end of my video. And then your problems that you have this week are all based on just what I've just talked about, okay? So you guys have some problems to do for Friday. All right, so on number 1, name the base and name the exponent. That should be singular. So the base is 5, and the exponent is, of course, 4. All right, number 2, what does 3 cubed mean? It means 3 times 3 times 3, which happens to be 27. All right, 2 to the 6th power, we have 2 times 2 times 2 times 2 times 1, 2, 3, 4, 5, 6. So I know 2 times 2 is 2. 2 times 2 times 2 is 8 times 8. So 2 to the 6th power is 64. All right, number 4, what is 4 raised to the power of 0? 4 raised to the power of 0 is 1. Number 5, we have negative 3 in parentheses raised to the 0 power, and our answer is 1. And number 6, we have negative 4 with no parentheses raised to the 0 power. It's going to be negative 1 because the negative sign is not in parentheses. All right, now let's look at these. I hope you guys are doing them with me. In fact, I'd love for you to pause the video and do these on your own. All right, letter 7. What? Number 7, so m is just in the numerator, so we're going to flip it down to the denominator, change, pass the line, change the sign, m to the first power. That exponent is positive. You can't have a blank in the numerator, so the answer is 1 over m. Of course, anything to the first power, you don't have to write a 1. What about number 8? 6 to the negative first. Well, the 6 must come down to the denominator. I would write 6 to the positive first, or just 6. 1, 6. 6 to the negative 1 is 1, 6. All right, what about 5 to the negative first? Well, 5 would drop down to the denominator. 5 to the first power can't have a blank in the numerator, so 5 to the negative first is the same thing as 1/5. Number 10, we have negative 3 outside the parentheses, so negative 3 stays negative 3. The exponent makes it drop down to the denominator, becomes a positive 1. You can't have a blank on the top, so the answer is, the whole fraction is negative 1/3. And then number 11, we have, same thing, negative 2. So negative 2 to the first power is going to be negative 2, right? So negative 2 is not going to change. It's still negative, but it drops, the negative 1 drops it down to the denominator. It becomes a positive 1. So my final answer would be negative 1/2. Negative 1/2. All right, you guys, so now you can try Friday's math problems. It's all examples very similar to these that you see here on the screen. All right, guys, I hope everyone has a good week. I'll see you guys at Advisement on Friday and math class on Monday.